Alright everybody, it's Mr. Rosen here again. Today I'm going to show you a little bit about something called the cosine law. So the cosine law, this is a law that you can use, or a formula you can use in trigonometry. Now, you're going to use it on triangles that are not right angle. So it's not the same as cos theta equals adjacent over hypotenuse. It's not the same as that. With this formula, it's going to be used for non-right angle triangles. So let's say we have a triangle ABC. You have to know how to label this triangle. So if the top angle is called angle A, the side across from it is called little a. The angle on the left is called angle B. The one across from it is little b. And the angle on the right is called angle C. The one across from it is little c. You do have to know exactly how to label a triangle in order for this formula to work. So let me write the formula out. So the formula looks like this for cosine law. It's a squared equals b squared plus c squared minus 2bc cos angle A. Now, that formula, in my opinion, is actually a bit of a pain to try to memorize. There's a lot of letters happening here, and it kind of fails as soon as you get into a triangle that's not ABC. So let me show you a way, like the logic of how you would sort of memorize this formula. And I'll do it with a different triangle. Let's call this triangle MNP. And let's say I want to find little m. I want to find that side length. Then the formula would look like this. You would write m squared, that's the one I want, equals the square of the other two sides, whatever they might be. So it'd be p squared plus n squared. Then it's minus 2 times the other two sides again, p, n. And then it's cos of whatever angle matches the very first letter of the formula. So this time would be cos m. So the way you think of this formula is, if I'm looking for m, it's going to be m squared equals the square of the other two sides, so p squared and n squared, minus 2 times the other two sides again, which is p and n, and then cos m. So the outer letters always match in a formula. Now the order, whether you do n and p or p and n, it doesn't matter the order. It's like saying 2 plus 3 is the same as 3 plus 2. They're both equal to 5. So the order really doesn't matter as long as after the equal sign is the square of the other two sides, whatever they might be. Okay? So if you understand that logic, that really helps, because then you can use it in any triangle that's not ABC, and you can use it even in triangles that are not even labeled at all. Okay? You might just have side lengths with no labels. So this is the cosine law. Now, when can you use this? So there's two very specific scenarios where you can use this. So when can you use it? When can you use? So the first scenario would be if you have a triangle, let's say it looks like this. Just make a quick example here. So 6, the angle will be 40 right here, and then 7. Okay? So this right here, this is known as an SAS triangle, or side angle side. What this is a side with an angle in the middle and another side. That is a scenario where I can use the cosine law. And in this particular triangle, I can get this side right here. I'll call it X. That's what it would give me. Okay? So you can use it in that triangle. You can also use it in a triangle where you know all of the sides. So let's say I have 6, 7, 8, something like that. And I know none of the angles, just the sides alone. This is known as an SSS triangle, which is side, side, side triangle. If you have that scenario, you can also use the cosine law. Okay? You can use the cosine law, and what it'll do is it'll give you an angle. Okay? So you can use, these are the two exact scenarios. If you have a scenario that looks like this, however, let me just make one up here. Let's say that's 70, this is 9, and this is 11. Okay? This is different. This is a scenario where I have an angle and a side across from it. So I have a pair of an angle and its opposite side. This one is actually sine law, and that's a totally different thing. And I do have a video on the sine law, but you would not use the cosine law on this triangle. So cosine law is only for these two scenarios. You have to have a side, angle, and a side. The angle has to be in the middle, and it has to be either a triangle with all three sides. So let's do an example where I work out one of each of these. So the first one, let's draw this triangle. I'm going to use A, B, and C for this triangle. You could use any letter you want though, it doesn't matter. Okay, so A, B, C. This is going to be 25 over here. This will be 40, 20 degrees. And what we're going to do is we're going to get little a right there. We'll get little a. So let's write out the formula. So the formula is going to be a squared equals the square of the other two sides. So b squared plus c squared minus 2 times the other two sides again. Cos angle A. So we're going to fill everything in as much as we can now. We don't know little a, so put a squared. Leave that. The b we know though. B is 40. It's across from angle B. So this is going to be 40 squared plus c. C is going to be 25, so that's 25 squared. Then it's minus 2 times 40 times 25. And then cos angle A. Angle A is 20 degrees, so put that in. So right now, I've got the whole formula filled in. It's just a matter of basically punching it in and solving this. Now, there's a lot of numbers here. I would advise you not to try to type all this in one shot. I always like to do one piece at a time and sort of build it up, okay? So the way I would do this is I would use my calculator and punch in 40 squared. That gives me 1,600. Then I would do 25 squared. That gives you 625. And then what I would do here is I would use my calculator and I would go negative 2 times 40 times 25 times cos 20. Do all of that last thing in one chunk. That's 4 numbers all multiplied together. When you do that in your calculator, and you should try it, you're going to get this number, negative 1879.4. That's what that should work out to on the end. Now, I've essentially got 3 numbers. I got an addition and a minus sign, so we're going to basically combine that all together. We get a squared equals, use your calculator and go 1,600 plus 625 minus 1879.4. Punch that in, you're going to get 345.6. Now we're almost done. We have a squared equals. What we want is a though. We don't want a squared. So the way we get rid of a squared is to square root both sides. If we square root the a squared, we just get a. And on the right side, if we square root 345.6, we're going to get 18.6. And that would be our answer for a. Okay. Now, it's a little bit of work. It's really not that hard. The hardest part is memorizing the formula, but really it's just a bunch of numbers you type in, use your calculator and solve it. Now, what is nice about this though is, let's say for example, this question, so I'm just going to put, this is 18.6 right here. Imagine this question asked me to solve the triangle. Solving a triangle means that you're going to find all of the missing angles and all of the missing sides. Right now, once I've got that 18.6, I've actually got a pair of an angle with its opposite side. I could then switch to the sine law. I don't have to use cosine law a second time. Cosine law is kind of big. There's way more ways of making mistakes, in my opinion, than the sine law. So we can switch into the sine law once we've already done the cosine law, because now we've got an angle with its opposite side. So just a little trick if you have to go any further in your triangles. Okay, so that's how we use the cosine law to find a side length. Now imagine we're given a scenario where we've got to find an angle. The angles are a little bit more tricky, so let me show you how that will look. Okay, so here's example number 2. And draw this thing out. It's not an accurate drawing. Okay, I'm going to call this M, N, P. Let's call this 5, 7, and 9. So this is a cosine law scenario because I know all 3 sides. I don't know any angles inside of it. Now, we can find any angle we want, but I'm going to look for angle N. That's the one I'm going to get right here. So if I need to find angle N, that means my formula must begin with a little n. So we're going to say it's n squared equals. It's the square of the other 2 sides. So m squared plus p squared minus 2 times the other 2 sides again. So it's mp. And then it's cos angle n. The outer letters always match in this formula. Now the idea here is I'm going to plug every single thing in this formula, including the little n. The only thing I won't have filled in is the cos capital N, because I don't know the angle. And then I'm going to isolate for that thing. So let me show you how this will work. Little n in this triangle is 5. So it would be 5 squared equals, little m is 9, so that's 9 squared. Little p is going to be 7, so that's 7 squared. Then it's minus 2 times m, which is 9, times p, which is 7. And then it's cos angle n. That's my mystery variable. I don't know that thing. So my goal is essentially I want to isolate this thing for cosine. It's a little bit of algebra involved. It's really not that hard, but that's the goal here. So how you do this is the steps that I would take. First thing I would do is, if you're thinking about BEDMAS, we're going to get rid of those exponents. We can do that right away. So 5 squared is 25. So let's take care of that. 9 squared is going to be 81. The 7 squared is 49. Now what I would do next is I would actually use my calculator and I would multiply these three things together right here. What this is going to do is it's just going to simplify the coefficient in front of the cosine. So in my calculator, I would go negative 2 times 9 times 7. When you do that, you get negative 126. Now the cosine is still attached to it. It's still being multiplied by cosine. So that doesn't go away. All we're doing is sort of simplifying the coefficient in the front. Now what we're going to do is we're going to collect our like terms. Now be very, very careful. We can't just go, like I'm looking at the right side here. I can't go 81 plus 49 minus 126. We can't do that because the negative 126 is attached to cos n. That means it's not a like term. It's not just a plain old number. So what we're going to do is take the 81 and the 49 and we're going to bring them to the opposite side of the equal sign. We're going to bring them both this way. And when we do that, we're going to change the signs. So as soon as you bring a number to the other side of the equal sign, it changes. A positive becomes a negative and a negative becomes a positive. So let's do that first. So we're going to get 25 minus 81 minus 49 equals, now what's left on the right side is minus 126 cos n. Okay. Now the left side, I've got three numbers. I got 25 minus 81 minus 49. That I can punch in my calculator and get my number. So let's simplify that. Punch it in, you will get negative 105. And that's still equal to negative 126 cos n. Now we're getting closer. We need to get the cosine by itself. The next step, what you would do is you would divide both sides by negative 126. If we do that, those will cancel out, leaving just cos n. But if we do it on one side, I got to do it on the other side as well. So the left side, I'm going to punch that in my calculator. I'm going to go negative 105 divided by negative 126. This is going to give me decimals. The decimals you're going to get is 0.8333. And I think it repeats. Okay? And that's equal to cos n. This number right here, my advice to you here is keep 4 digits no matter what. If you're to write just 0.8, okay, you're going to round that too much. And when you get your final angle, it's going to be a little bit inaccurate. Okay? Try to keep as many digits as you can at this stage. 4 is a good number. And then what we'll do is we'll round it at the very end once we figure out our angle. So the last step is to convert this decimal into our angle. So the way we do that is we basically use second cos. So we're going to say second cos of 0.8333, that's going to be equal to angle n. And when you punch that in your calculator, you get 33, let me erase that. 33.6 is what you get. That's what n is. Now, sometimes people might round that. You might say that, angle n is going to be 34 degrees. And that might be your final answer. It depends on the question. A lot of times questions will say round to the nearest whole number for angles. But that's how this would work, okay? So cosine law, every one of these questions is basically the same. You just got to take your time and methodically work it out. It's just a lot of calculations, a lot of numbers. When you find an angle, your goal is to isolate for cos n and get a decimal for that thing. Once you got a decimal, then you're going to hit second cos and you're going to turn that into an angle. And now the nice thing about that is, so I've got angle n is 34. So just like our previous scenario, if I know that that's now 34, I could then use the sine law to continue. If I had to get angle P, for example, I would go sine P over 7 equals sine n over 5. and I could solve that. And sine n would be sine 34. So you could switch to the sine law now that I've got a pair of an angle that's opposite side. You don't have to do cosine law 3 times to get all of the angles. Okay? So this is just a quick little demonstration of the cosine law. I showed you the formula. I showed you how to solve for a missing side length. And I showed you how to solve for a missing angle. Missing angle is more work, in my opinion, a little bit tougher, more ways to make mistakes. But it is very repetitive. If you get another triangle that's a side-side-side triangle, it's the exact same steps, just different numbers. Okay? So hopefully that makes sense for you, and try out this formula.